Guys, we really need to check the harder question we did last week. Number 6, again. This is called the dynamics. Question 6. It's part of mechanics. But we changed the number. We changed all the numbers. Because last week we did with those numbers. Here, 2.0, 3.0, 4.0, 5.0. Okay. Me with grammar school headmaster. And our, leader for the whole New Zealand. Okay. Everybody check. Yeah. If you can do the questions. A, I didn't change anything. We need to redo question 6. This question about force, not easy. Not easy. Guys, redo these 5 questions. If you got the answer, message me. Oh, yeah. Okay, all the diagrams same. You just pretend the lift with load all together. How many kg? This one, how many kg? Ben, 3,000 Newton load. How many kg? Good, but that's the answer for year 11. But this year we need to divide by, yes. So we have 305.8 kg. Okay, so in total we have, 480 plus 305.8. In total, we got 785.8 kg. So, all question A, B, C, D, E, same diagram, almost same diagram. Here, this much times by G. That's called the weight. Okay? And the lift got a cable. The cable gives tension up. This is called the tension. Tension, like the force in the string or in the cable. So we have 2 forces on the load, the lift with load. We consider the lift and the load together. We consider together. Now for question A, answer the question. 裴鑫, for question A, what happened for weight and tension? What's the relation between T and W? Hey, this is kinda almost just year 11. Ben, for question A, what's the relation between T and W? If the speed constant here, yeah, constant, but You know, if for this motion, just moving up and down, right? If speed constant, what's the acceleration? Which is, yes, for A, acceleration equals 0, which means all forces balanced. So T equals W. Doesn't matter which way. Maybe moving up, constant velocity. Oh, resultant force 0, because no acceleration. Because if you have acceleration, we got a resultant force. This one acceleration 0, which means resultant force 0. Eh? What's the resultant force? You got many forces exerting on the object. Those forces give you same effect as a single force. That single force is called the resultant force. Okay, single force is called the resultant. So acceleration 0, resultant force 0. Resultant force 0, which means barrier T equals W. T equals W. So you can calculate the T, just mg 785.8 times 9.81. Write your name using permanent marker. Okay. Write our name using permanent marker. So the answer for A, same as last week. Same as last week. Barry, what's the answer for A? Okay, which is 7,708.698 Newton. But you can round to 2 SF, just this much Newton. We are doing question 6 again. Question 6 again. We did number 6 last week. Hey, you guys missed my picture. Paul Scott Smith in the background. This is my student. I got several students on the honor board. Cool. We expect that. Yeah. Honor board not easy. You need a A-level average 90-something%, or NCE scholarship 3 or more, like that. Yeah. Because my boy on the board, so I go to the ceremony. Okay, that's question 8. Yeah, my boy graduated last year. Okay, this is AR. We just check TW. W is kind of fixed, or just 7700 Newton. So you just need to determine T. Okay, you just need to determine T. If we try to make the idea more simplified, More simplified. Check here. For part A, then for question A, the lift moving constant speed. What's acceleration? Good. Acceleration 0. So the resultant force 0. Resultant force 0 means T equals W, which means 7700 Newton. We try to make it shorter. Okay, B. Ben. They told you accelerating, moving downwards, accelerating, right? Which means acceleration is downwards. Guys, the lift moving downwards, accelerating, which means acceleration downwards. Acceleration downwards. Total resultant force downwards. Which means if the total resultant force downwards, that means, check here, the downward force is larger to provide the downwards resultant force. Only the force downwards larger, you have total force downwards. And we learned the resultant force equals ma. So you can calculate the T. Guys, I just changed the numbers from 1.5 to 2, 3, 4, 5. Okay, try to finish the question B. Yeah, because a lot of schools learning very slow. We're too fast. So we also can slow down a bit. Guys, try to finish question B. Because M just 785.8 kg. Acceleration just 2.0. Calculate T.
Is that 7,700 minus tension?
Yes, because 7,700 Newton downwards, tension up. Because tension is the cable in the cable, like try to pulling the lift on. So that's why resultant force is mine. Okay. So guys, you really just need to double check. Acceleration downwards, that means the force downwards is larger to make a resultant force downwards. Yeah.
Why is like if resultant equals to 700 minus T?
Or resultant, because when you do the resultant here, for example, if someone pulling you that way 10 Newton, another guy pulling you 8 Newton up, what's the total force you experience? Yes, so you just use 10 minus 8. Yeah.
Why is it 2?
Oh, I changed the value. Try to redesign the question. We try to redesign the question. Question B. Barry, what's the answer for question B? For question B? 9,000? Really? Is this equation just like year 9? Is this equation just year 9? 4.9 thousand? Okay, guys. It's if you need a t, you need the 7700 minus.
Is it 6,131?
Oh, that one look better. Hey, calculator. Oh, you grab my calculator. Okay, it's okay. Uh, 6,000. Anticipate we can you're not working 6,000 what like this. So Lucas got correct. Okay. You really got something. Okay. Oh. Okay. Oh, because we try to make this notes a bit better, so I rewrite important part now. We need to calculate the tension. The tension. Okay, check the key idea on. We change here to 2, change here to 3, change here to 4, change here to 5.0. So for question B, you have weight downwards, tension up, but acceleration downwards. In this case, ma just equals 7700 minus t. That's about the resultant force. You can use W minus T equals F. Yeah. Oh, because we try to find the total force, right? Like if you got this one downwards, if you got 5,000 upwards, do you know the total? Yes, very good. Just why we minus them. Okay. Muya, any question? Okay, that's B. Let's double check C. Again, we have this much downwards, something upwards. Burial. The acceleration for question C, downwards or upwards? Very good, because the elevator moving downwards, but decelerating, which means acceleration opposite. So if acceleration upwards, we need T minus this equals ma, which means tension is larger now. Tension is larger now. Well, only total force up can provide acceleration up. Okay? This question very important. Oh, we did ma already. Oh, not already. We next step we just sub value into it. I'm just this much. Oh, okay. We actually got here in previous part. 480 times 9.81. This much Newton. So in total, 7,700. You guys try to be here earlier next week.
Is it 10,000
Oh, we need times the acceleration, which is 3 now.
10,005.
Oh, look good. Yes. If you round it, just around 10,000 Newton. Oh, yo, Ben, do you really understand the tension is larger?
Yeah.
Okay, because acceleration up. So the force upwards must be large. If force upward equal force downwards, acceleration 0. If force upwards less than force downwards, acceleration downwards. Okay,
Like
so
when resultant force is like 0, that's like constant.
if a resultant force 0, that means velocity constant, but acceleration is 0. Okay. Raymond D. Just tell me acceleration up or down. Very good. If acceleration up, T minus W equals ma. The force upward larger. So T minus 770. Oh, this acceleration is 4 now. Okay. Do the calculation, guys. Do the calculation. Yep.
Do you ever make your calculator?
Oh, yeah. Okay. So D. Burial D. This much? Really? Okay. One more here. You're right. All right. E. Wait. For E, you need to tell me acceleration up or down. Good. If you move up, but deceleration, acceleration downwards, which means W is larger, T is smaller. So 7700 minus T equals ma. Acceleration just 5. All right, what's your answer?
3761.
Okay. That's here. Oh, in the working, you better write or answer the longer one. And you round it. Okay. So this question just for different cases. You need to decide direction of acceleration first. If acceleration up, the total force up. If acceleration downwards, the total force downwards. Zane, any question?
Where did the 3771 come from?
3771. Oh, you do this calculation to calculate it. Yeah. If you don't like doing algebra, try to find a better calculator. Whoa. It's really essential. 1 year, a ma.lift guy, school exam, always 40%. I just taught him how to use calculator. His final result, 60-something%. he is running some visual something studio now. Okay. Okay. Yeah. Oh yeah, I forgot his last name. Maybe something Stone. Something Stone. That's a long time ago. Okay. Guys, understand this idea? This question really, really important, okay? Really, really important. And those like some typical examples of Newton's second law. It's about acceleration and the force. Okay. I think last week we start